So what I'm going to talk about in this video is how to determine the probability of finding an electron in a certain segment of a 1D particle in a box. In this case right here, we're going to be looking at the n equals 2 energy level, and we're going to be looking at the region between essentially the 3L over 8 point and the L over 8 region in those cases. And so if we were to draw, just as a means for ourselves, what that wave looks like, it looks like this right here, we have one node that's at L over 2. And so we have a peak here at L over 4. And so what we're looking at, is from the 3L over 8 to the L over 8, So that's going to then be, so this is the L over 8 right here, and then this is 3L over 8 right here. And so what we're doing is trying to figure out what's the probability of finding that electron in this box, in that shaded region right there. And so unlike a really clean and easy one, like I had done in a previous video, for this one, you're actually going to have to use an applied calculus to be able to figure it out. Because it's not very obvious what the percentage really is in this case right here, You can get a good idea roughly of what it is, but if you really need to nail down what the value is, you're going to actually have to use calculus. So if we look at what the wave function is, the wave function of a 1D particle in a box is equal to the square root of 2 over L times sine of n times pi times x over L, And so n is the principal quantum number of the energy level you're looking at, Pi is pi, x is the position, and then L is just simply the length of the box. So probability, is just simply the wave function squared. So if we square this, so we have squared, what we get is 2 over L times sine times, sine squared, of n pi x over L. So if we're trying to figure out what the probability is of those two regions, we're going to have to integrate, that probability equation, in terms of x. And so if we do that, what we get then is simply, 2 over L simply isn't part of the integral, We can simply pull that out, All we're doing is integrating the sine squared, because that's the part that includes the x. And so what that equation then is, excuse me, is going to be that you have, the x position, of the second position there, is going to be x over 2 minus L times sine times 2 pi n x, of that position we're looking at, over L over 4 pi n minus, the x position of the first position there, over 2 minus L times sine of 2 pi n x1 over L over 4 pi n, And so that you have that right there. And so now all we have to do is just simply for x, put in what those two different areas of the wave function that we're looking at, and then also our principal quantum, our n equals 2 value. So if we do that, we're going to have 2 over L still on the outside, and so we have x2, so that's just simply going to be then 3L over 8, and that's going to be over 2 minus L times sine of 2 pi n, Actually, you know what? We can just simply throw in what our numbers, So that's going to be 2 in this case times x, So that's going to be 3L over 8 over L over 4 pi n minus, now x1 is going to be L over 8. So we have L over 8 over 2 minus L times the sine of 2 pi over 2 times L over 8 over L over 4 pi n, or not n, sorry. It's 2, and I realized that I left the n over here as well, so this is a 2. So we have all of these values in these cases, and so now all we have to do is just simply do the math on everything for it to all work its way out. So what we can see here, is that what we'll have is, still the 2 over L. Here, we're going to have 3L over 8 to 2, So that just simply gets converted into being 3L over 16 minus So if we look over here, right, we have sine, and so we have these L's right here are going to cancel out. And so we have 2 times 2, which is 4. And so 4 times 3 is 12. 12 divided by 8, right, is going to give us 1.5. And so the sine of 1.5 pi is going to be equal to -1, right? And so we have -1 L over 4 pi times 2, right? And so we can just simply ease that out for ourselves as well, right? And just simply make that 8 pi right there. So we have that part done, minus, and so now, right, we have L over 8 over 2, so that simply gets simplified out to being L over 16 minus, and now, right, what we're looking at in this case, I don't know why I drew a line there. Right, what we have here now is going to be that the L's are going to cancel out within the sign, and so we have 2 times 2 over 8, right, so we have 4 over 8, so now what we're looking at is the sine of 0.5 pi, and so that comes out to being equal to 1, and so now that just simply becomes L over 8 pi in this case. And so if we add all of this up, right, what we get then is 2 over L times 2L over 16 plus L over 4 pi. And so if we multiply, essentially that 2 over L by those 2 points right there, what we get is 4 over 16 plus 1 over 2 pi. And now we can just simply plug that into our calculator, right? We can, we know what pi is in that case. And so what we get then is 0.409, right? So we have a 40.9% probability of finding an electron in a 1D particle in a box model in the L over 8 to 3L over 8 region when n is equal to 2. And that's how you approach that.